There are some galaxies out there that have very little starlight at all. In fact, they might not contain any stars like we normally think of them. They're dim and mysterious, and scientists suspect that these so-called dark galaxies might be more common than the ones we can actually see. Let's talk about what exactly these strange objects are and why astronomers are trying to find them. This is our channel. I have a question for you. What do you think makes up most of the stuff we can see in the universe? Is it stars, planets, black holes, galaxies? Well, if you picked something other than dark matter, you'd be wrong. Dark matter is thought to make up 80% of all matter in the universe. It just doesn't interact with baryonic matter, which is everything we're made of very much. So we can't see it directly, we can only observe its gravitational effects. And since dark matter interacts so weakly with regular matter, it probably doesn't form stars in the way we understand them. And while dark matter is an essential ingredient in galaxies, it's far from the only one. Galaxies also need a bunch of regular matter, things like hydrogen and helium, and some amount of energy in order to form. Without those things, gravity wouldn't be able to pull everything together. But in some cases, the balance of dark matter to regular matter could be drastically different than what we see in galaxies like our own. And that means some galaxies could be mostly dark matter, or at least appear that way because of how we detect them. If a galaxy has a lot of dark matter relative to regular matter, that would make it harder to see because there'd be less of the stuff we can actually detect. That's not to say we couldn't see these galaxies at all, but it does mean they would be really faint. It's kind of like how a neutron star can look like a tiny speck of light against a backdrop of stars when it's really hundreds of thousands of light years across. The key difference between a neutron star and a dark galaxy is that the galaxy has a lot more mass. So, in theory, if two galaxies collide, a collision that brings together a dark matter-dominated galaxy and a regular galaxy like ours, the result could be a galaxy that appears quite dim compared to others. These hypothetical dark galaxies may already have been identified by telescopes like the Hubble Space Telescope, but they might have been mistaken for something else. For example, they might have been classified as dwarf spheroidal galaxies, which are small, faint galaxies that have a symmetrical shape, or they may have been identified as dark dwarfs. This is a tentative class of galaxies that are too small to be detected with normal optical wavelengths of light. Instead, they can only be detected through their gravitational effects on other objects. But there's another way that a galaxy can become dark, too. Not every galaxy starts off that way, but over time, they can lose most of their stars. This would happen if a galaxy had most of its stars ejected from the system. Now, this isn't impossible. Astronomers have observed super outflows of material from some galaxies. These are gigantic cones of gas shooting out from the center of the galaxy. If something causes the stars to fly away from the galactic center, then gravity may not be strong enough to hold them all together anymore. The galaxy will expand until the remaining stars aren't bound to each other at all and they lines drift apart. Now, the thing is, we don't know what exactly happens to these lost stars. They could be stripped away from the galaxy forever. But another possibility is that they wander into the intergalactic medium, which is the stuff between galaxies. In that case, they'll eventually get absorbed into another galaxy. So while the galaxy that lost its stars is now dark, those stars aren't lost to the universe. They're recycled and used to make new stars elsewhere. This could happen gradually over billions of years, or it could happen all at once. For example, a supernova explosion in a small galaxy could blast stars out into space and leave behind a dark galaxy filled mostly with dark matter and dust. This idea is supported by the fact that there seem to be a lot of supernovae happening in the early universe, according to data from the James Webb Space Telescope. While we normally think of supernovae as events that create new elements, like iron, for example, they can blow a lot of pre-existing elements out into space, too. The good news is that even though dark galaxies are difficult to detect, they do leave behind a telltale signal. Their gravity, specifically, their gravity warps the fabric of space-time around them, which can magnify and distort the light from objects that are much farther away. This is called gravitational lensing. Lensing can happen when light passes by anything with a strong gravity field, not just a galaxy. It's why we know that there are a lot of dark matter-only objects out there, things that are too small to be seen otherwise. And in some cases, dark galaxies might not be dark at all. There's a class of galaxies that emit a lot of radio waves, which means they're emitting a form of light that we can detect. Unfortunately, the exact mechanism behind why these galaxies emit so many radio waves is still unknown. They're known as radio galaxies, but some of them might technically be dark galaxies too. They just happen to be emitting light outside of the visible spectrum. Not only that, but their outflows can produce jets of material that extend tens of thousands of light years beyond the galaxy itself. And those jets produce a lot of radio waves. However, just because something emits radio waves doesn't mean it's a dark galaxy. A galaxy can become a radio galaxy under certain circumstances. Maybe it's going through an unusual event like colliding with another galaxy. So, just because a galaxy appears dark doesn't mean it's a dark galaxy. In reality, it's pretty hard to tell without more data. The James Webb Space Telescope might be able to help sort things out by looking at the chemical signatures of various galaxies. Because different types of matter absorb and emit different wavelengths of light, astronomers can use spectroscopy to identify the chemical composition of distant objects. With this tool, they can determine if a galaxy is mostly dark matter or if it's mostly regular matter, or hopefully narrow down the possibilities. For example, there are a few observations that suggest the universe might contain a lot of dark galaxies. One is that the web-like structures that connect galaxies across the universe seem to have more structure to them than expected. If all the galaxies we see are mostly dark matter, that would make sense because dark matter interacts very weakly with itself. And so the structure of these dark galaxies would mirror the structure of the dark matter that makes up their halos. Another piece of evidence comes from computer simulations that show that dark galaxies should be more common than the ones we can actually see, but here's where things get weird. Some astronomers hypothesize that dark galaxies are actually more numerous than regular ones, meaning there could be more dark galaxies than ones made of regular matter. Now, this is wild because there's a lot of regular matter in the universe. You just have to think of all the stars, planets, clouds of dust and gas and whatnot. If there are more dark galaxies than regular ones, that means there's more dark matter in the universe than regular matter, which goes against what scientists currently believe. Then again, maybe this isn't the case at all. Maybe there are just as many regular galaxies as dark ones. Maybe dark galaxies are just as common as the ones we can see. We simply haven't found them yet. To figure this out, scientists are going to need more data and better tools. Enter the Nancy Grace Roman Space Telescope, which is scheduled to launch in the mid-2020s. This telescope is designed specifically to find dark matter, dark energy, and exoplanets. But it should also be able to spot dark galaxies. It'll be able to measure the gravitational field of over 1 billion galaxies, which should give astronomers a better understanding of what's out there. It'll be able to detect things that are way too small to be seen by other telescopes. But we'll have to wait a bit longer to get its results. In the meantime, there are plenty of other telescopes doing their own thing. For example, the Square Kilometre Array is a radio telescope currently under construction in South Africa and Australia. When it's finished, it'll be the world's largest radio telescope. With this instrument, astronomers should be able to study the jets coming out of radio galaxies in unprecedented detail. These studies could provide clues as to why these galaxies emit so much radio energy. And if it turns out that these emissions are a sign of a dark galaxy, then the square kilometer array should be able to find many of them. So there's a lot of work to be done, but we've got the tools we need to finally uncover the mystery of dark galaxies. And with luck, we'll find out if there are more of them than the ones we can actually see. Thanks for watching this episode. If you would like to help support our channel, we have a platform where you can support things like this. You can check out our platform link in the description below. And as a little show of our appreciation for the platform, we've got a special message for you. We'll see you next time.